Repairs that can instantly void your boat insurance, ranked from common shortcuts to concealed disasters. From the innocent $5 fix at the hardware store to hidden modifications that make your entire policy worthless, every repair on this list is a red flag for surveyors and a claim killer for insurers. Some will raise your fire risk, some could sink the boat, but all of them can cost you everything without warning. Which shortcut tops the list? Let's start with number 10. Orange wire nuts, the twist on connectors you would use in a basement, show up on boats more than you would believe. A BYC standard E11 bans them outright, but they still pop up under cabin soles and behind breaker panels. Boats vibrate. Every wave, every engine start, every slammed locker door shakes those joints. Fine stranded marine wire works loose inside a wire nut, and contact resistance climbs. That is when the heating starts, plastic softens, insulation carbonizes, and the connection arcs. You will not smell smoke until the fire is already chewing through plywood, or the bilge pump wires have fused into a blackened lump. Surveyors know the look: melted orange caps, scorched conductors, the telltale burn pattern of a silent fire. No insurance adjuster will pay a claim when they find a hardware store connector where a marine-grade crimp should be. The verdict is not a warning, it is immediate failure. If you find a wire nut on your boat, cut it off and replace it with a tinned, heat-shrink marine crimp. Anything less is just a fire waiting for an excuse. Solid core yellow Romex, NMB cable straight from the hardware store, shows up in bilges and lockers like a bad penny. On land, it is legal and cheap. On a boat, it is a silent fire hazard. Solid copper cannot flex with the hull. Every engine vibration, every chop, works that conductor like a paperclip bent back and forth. Sooner or later, the copper inside the insulation cracks. You will not see it. You will not smell it. But under load, that hairline crack turns into a tiny arc. The insulation starts to melt from the inside out. Sometimes the first sign is a scorched patch of wood or a breaker that will not reset. A BYCE 11 mandates stranded, tinned cable for exactly this reason. Surveyors do not need to see the crack. They just spot the yellow jacket and write "Fire Hazard Exclusion" in the report. NMB cable is not rated for oil, heat, or vibration. It fails the moment it is installed. If Romex is hiding behind your panel, you are gambling your hull on a few dollars saved. The only fix is to rip it out and rewire with proper marine-grade, stranded cable. Anything less is a denial letter waiting to be mailed. White PVC pipe and a hardware store ball valve, two parts that cost less than a dinner out. But when they are used as a through hull below the waterline, you have just written your own sinking report. PVC Schedule 40 is not built for the marine world. It goes brittle after a year in the sun, chalking and cracking with every flex of the hull. Drop a heavy wrench or hit rough chop, and that pipe can snap clean, leaving a full borehole wide open to the sea. A BYC H27 sets the minimum. Seacocks and through hulls must survive 500 pounds of pull without breaking. PVC fails that test every time. Surveyors see the white plastic, check for softness, and write one word: unseaworthy. Insurance adjusters do not argue. When a PVC fitting fractures, water pours in at hundreds of gallons per minute. The boat sinks before you even find the leak. Every year, claim files stack up: flooded cabins, total losses, all denied for non-compliant installation. The fix is simple: haul out, rip out every inch of PVC below the waterline, and install ABYC approved bronze or Marlon Seacocks. Anything else is a catastrophe waiting for the next dropped toolbox. A Delco Remy alternator stripped from a junkyard car costs $60 and looks shiny on a workbench. But mounted in a gasoline engine compartment, and you have just wired a detonator to your hull. Automotive alternators have open vents and exposed brushes. Every revolution those brushes spark, tiny arcs invisible in daylight, but deadly in a bilge soaked with gasoline vapor. Gas fumes are heavier than air. They settle low, pooling beneath the engine. It takes one stray spark to ignite a vapor cloud, and the result is not a warning shot. It is a hull-shattering explosion. The US Coast Guard catalogs dozens of these blasts every year. Insurers see the pattern: a non-marine alternator, no SAEJ1171 marking, fireball, total loss, claim denied under explosion exclusion. Marine alternators like Balmar are built differently. They are sealed or screened and tested to SAEJ1171. That label means they cannot ignite a flammable atmosphere under any failure mode. Surveyors look for that stamp: no marking, no coverage. If you find a car alternator on your gasoline boat, replace it with a certified marine unit before your next trip. This is not just about passing inspection. This is about not turning your boat into a crime scene. Saving $300 is never worth a blast that takes the whole vessel with it. A brass gate valve under the waterline is a time bomb disguised as plumbing. Most of these valves start life in a hardware store, stamped brass with no alloy marking, meant for basements and irrigation, not seawater. The problem is dezinsification. Salt water pulls zinc out of the alloy, leaving behind a spongy pink copper shell. Outside, it might look fine. Inside, it is crumbling. Surveyors know the test. Tap it with a screwdriver. If the metal flakes or turns dull pink, it has already failed. Practical Sailor has warned for years that these valves can snap off in your hand, or worse, when you try to close one during an emergency. Brass gate valves are not designed for hull pressure or constant immersion. They were not tested to ABYCH 27 500-pound pull standard. If a heavy object lands on that valve, or if you wrench it shut in a panic, it can shear clean off, leaving a full bore hole below the waterline. Flooding is instant and total. Insurers treat a brass valve failure as owner neglect. Improper component selection is all it takes to void a sinking claim. The only fix: swap every brass valve for a true bronze seacock stamped with an alloy code and pressure rating. Anything less is just a pink porous ticket to a denied claim and a sunken boat. Verdict: sinking hazard. A loose car battery in a boat is not just sloppy. It is a direct line to an engine room fire. A BYCE 10 spells it out. Every battery must be secured in a box or tray, tied down so it cannot shift more than 1 inch, and protected against accidental short circuits. Walk through any marina and you will find automotive lead-acid batteries wedged under steps, sitting on plywood, with nothing but gravity holding them in place. The danger is simple physics. A wake hits, the battery tips, and the positive terminal slams into the engine block or the fuel tank. Suddenly, you have a 1000 amp arc, enough current to melt copper, vaporize insulation, and set nearby hoses ablaze. The cable glows red, the bilge fills with smoke, and if the battery vents hydrogen gas, a single spark can turn the compartment into a blast zone. Insurance investigators know the aftermath: scorched wiring, blistered paint, and a denial letter citing ABYCE 10 violation. No tie-downs, no box, no main fuse within 7 inches of the positive post, no coverage. Every unsecured battery is a rolling fire hazard. The fix is non-negotiable. Install a proper marine battery box, strap it down, and add a main fuse at the source. Saving time here just hands your insurer the excuse they need to walk away from the claim. A cleat glued to the deck with 3M 5200 looks clean, no bolt heads, no backing plate, just a bead of white sealant and the illusion of strength. The problem is simple physics. 5200 is a powerful adhesive and a great sealant, but it is not a substitute for through bolts and proper backing. Even 3M's own tech sheet warns, adhesive strength is no match for shock load or peel force. Under a steady pull, 5200 can hold thousands of pounds. But boats do not live in the lab. When a dock line snaps tight in a squall, or a crew member grabs that cleat during a man overboard, the load is not slow and steady, it is instant and violent. That is when the glue peels away from the fiberglass, sometimes tearing up a chunk of deck, sometimes letting the hardware fly free. A glued-only stanchion or cleat does not just fail, it becomes a projectile, and the deck is left with a hole right when you need it most. Surveyors call this improper installation. No mechanical fastener, no insurance coverage. No adjuster will pay a claim when a critical fitting rips out because it was glued, not bolted. The fix is non-negotiable. Every load-bearing fitting must be through-bolted with a proper backing plate and sealed with 3M 5200 as a gasket, not as the only anchor. Anything less is just an accident waiting to punch through your policy. A Coleman camp stove on a galley countertop looks harmless, until you realize what is happening below deck. Propane is heavier than air. The moment a green 1-pound bottle develops a leak, gas sinks, sliding off the table, pooling in the bilge and every low spot. There is no smell, no warning. One click of a bilge pump, a spark from a corroded switch, and the entire cabin erupts. The United States Coast Guard catalogs liquefied petroleum gas explosions every year, charred hulls, blown-out decks, sometimes fatalities. In almost every case, investigators find the same setup: a portable camping stove, a disposable cylinder, and no vented locker. A BYC A20 does not leave room for debate. All liquefied petroleum gas cylinders must be stored in a sealed, vented locker that drains overboard. No exceptions for a quick meal or because it is raining outside. The standard exists because even a teaspoon of leaked propane can turn a 30-foot sailboat into a bomb. Insurance companies treat this as gross negligence. If a claim comes in after a propane explosion and the adjuster finds a green bottle under the sink or a camp stove on the chart table, the verdict is absolute exclusion. The policy might as well not exist. United States Coast Guard safety alerts and insurer bulletins hammer the same point. Portable liquefied petroleum gas inside the cabin is forbidden. Every year, dozens of fires and explosions are traced to these setups, and every year claims are denied. The solution is simple. Remove all camping cylinders from the cabin and install a marine-rated liquefied petroleum gas system, a vented locker, marine hose, regulator, and shut-off solenoid. Anything less is a time bomb. The fix costs a few $100s. The alternative is a denied claim and a hull split open by a blast. If you see a camp stove or green bottle in your cabin, get it off the boat now. The insurance industry calls this one absolute exclusion. A lithium iron phosphate battery labeled as a drop-in replacement slides into the old lead-acid tray. The terminals fit, the lights come on. But what is happening under the deck is anything but plug and play. Lithium cells are hungry. They pull every amp your alternator can give, and they do not taper off like a lead-acid bank. Instead, they drag the alternator to full output and keep it there, hour after hour. The alternator runs hot, insulation starts to soften, and the diodes strain under the load. Most marine alternators were never designed for this kind of abuse. Without a dedicated lithium charge controller or an alternator temperature sensor, the windings can overheat and fail. Sometimes the first sign is a burning smell in the engine room. Sometimes it is a full alternator fire. Now add a bargain bin battery management system, the BMS, inside many drop-in lithium packs. When it senses an overvoltage or overcurrent, it does not play nice. It simply opens the circuit, instantly disconnecting the battery from the system. The alternator, still spinning at full speed, suddenly loses its load. Voltage spikes slam through the DC bus, frying sensitive electronics and sometimes blowing apart the alternator's own diodes. In worst cases, the alternator housing gets hot enough to ignite nearby wiring or insulation. This is not a theoretical risk. A BYCE 13 spells out the requirements. Every lithium system must include a BMS that coordinates with chargers and alternators, and the charging source must ramp down safely if the battery disconnects. No exceptions. USCG safety alerts and manufacturer manuals all warn the same thing. Lithium is a system redesign, not a swap. If you install a lithium iron phosphate pack without a BMS that talks to your alternator, without lithium-specific regulators, without fuses sized for the higher current, you have just created a non-ABYC compliant modification. Insurance adjusters see the melted alternator, the scorched wiring, the evidence of a thermal runaway, and stamp the claim denied. The verdict is clear. Lithium drop-ins without proper integration do not just void coverage, they turn your engine room into a fire scene. If you want lithium, treat it as a full system upgrade. Anything less, and you are gambling your hull on a $10 BMS. A resin glassed over Keel Bolt cap looks tidy, no rust, no weeping, just a smooth dome where the bolt head should be. But beneath that shiny cover, a silent killer is at work. Stainless steel needs oxygen to resist corrosion. Trap it under fiberglass and resin, seal in a little bilge water, and you create textbook conditions for crevice corrosion. Chlorides from salt water migrate into the void, and with no fresh air to break the cycle, the bolt corrodes from the inside out. What starts as a cosmetic fix becomes a time bomb at the heart of the hull. Surveyors call this concealment of defect. It is not just a bad repair, it is a red flag for fraud. Forensic reports after keel failures read like crime scene notes, glassed over bolt heads, hidden rust streaks, bolts that snap clean when tested. An owner may claim ignorance, but the evidence is hard to argue with. Encapsulated bolts rot in secret until the day the keel lets go, sometimes with no warning. The entire boat can be lost in minutes. In the worst cases, lives have been lost because a hidden defect went undetected until the hull split open at sea. Insurance companies treat this as misrepresentation. If an adjuster finds signs that a known problem was hidden, especially something as critical as a structural bolt, the policy is dead on arrival. The claim file fills with words like non-disclosure, concealment, and willful neglect. In legal terms, it is grounds for voiding the contract. Even if the failure started as simple corrosion, the act of hiding it with resin turns the owner into a participant in their own denial letter. Courts have sided with insurers in these cases, ruling that a hidden defect is not an accident, but a preventable loss. The only responsible fix is brutal honesty. Haul the boat. Grind away every glassed-over patch. Expose every bolt head. Use torque wrenches, ultrasonic testing, dye penetrant, whatever it takes to know the true condition. If a bolt is suspect, replace it. If the keel is compromised, drop it and rebed. Document everything, photograph before and after, and bring in a surveyor to sign off. Anything less is gambling with the entire value of the boat and the lives of everyone who sails on it. The verdict is absolute: concealment of defect. Claim void. If you find resin over a keel bolt, stop, remove it, inspect, and repair. The next hidden crack could be the one that separates your hull from your future. Across all 10 forbidden fixes, one truth emerges. Insurers and surveyors treat non-marine repairs as invisible, no matter how well-intentioned. The real threat is not obvious sabotage. It is silent non-compliance hiding in plain sight. Every shortcut gambles with your entire policy, not just your boat. In marine safety, there is no such thing as good enough. Only standards keep you covered. Which banned repair have you found lurking below deck?